LK, that's apidum.lk. That's about professional diploma in digital marketing, the main intake. Now let's get connected with our panel today. Now, today, the second day of the Internet of Things short course, we are going to talk about keeping the Internet of Things alive. Now, today's session will be on IoT enterprise architecture, IT support versus supporting an IoT, and walkthrough of support use cases and their challenges. And the panelists for the day will be Ishrat Ahmed, the product support manager at Zone 24/7. Ishrat, please come online and greet the audience.
Hi everybody, good evening to you all.
And Heshan will be joining us today as well as another panelist or another resource person today. Heshan.
Hi everyone.
Yes, and Asanka will be joining us as a panelist today. He won't be presenting, but he'll join us as a panelist. Asanka.
Hi everyone.
Perfect. So we have all the panelists online today, but before I actually hand it over to the panel, I'm going to ask you a question. In fact, I'm going to prompt a poll. I'm going to prompt a poll on your screen. You are going to vote on this poll because we are delivering this program through Zoom, right? And we got to know that on Monday, quite a lot of people couldn't join the program live because we have this limitation of 100 participants on top of the panelists, right? A lot of people actually couldn't join the program and they later actually contacted us. So what we did was we shared the recording link with them. Now, today, I already see 90 odd people connected, right? I'm going to push this poll to all of you. You are going to vote on this. Let me first trigger the poll. The question that I'm going to ask is, did you connect live to the first session? Or you have three options: yes, no, but watch the recording, or no, didn't watch the recording either. So I'm going to launch the polling. Please pardon me with some of the spelling mistakes, but you are going to get the message anyway. So I'm launching the poll. Please keep on voting and I'll get the vote count and then we'll get an understanding about what type of an audience we are having today. All right, I can see the votes coming in. We have 60 odd votes out of the 89 participants. All right, I'll give you 15 seconds. We'll get all the vote counts fast as possible. If you haven't voted, keep voting. All right, so I'm going to end the poll now and I'll share the results with you. Now, according to this, 57% of today's audience, they have connected live with us on Monday, and 11% they didn't connect live on Monday, but they have watched the recording, and we have 33% they are connecting for the very first time today. They haven't watched the recording. So for their benefit, I'm sure Heshan is going to do a quick recap of what we covered on Monday. And I recommend you to find the video. I mean, it's uploaded on YouTube. It's uploaded on Apidum YouTube channel. You can watch the first day video there. And we are going to upload this as well. But recommended to come join us on Friday live after watching both the sessions. Okay, Heshan, so I'm handing it over to you. So you can actually give a quick recap for the 33% of the audience, 25 people to be precise, a quick recap of what we have covered on Monday.
Sure, Amita, we'll do that. Okay, so first let me share my screen. I trust everyone can see the presentation, right?
Yes, sir.
Okay, great. Right, so good evening everyone and thanks for joining back. So Kamita said, for the benefit of those who did not, who were not able to view the previous presentation, the previous session, well, let me quickly give you a recap. So day one was all about discussing what the Internet of Things was or is. So we discussed this topic in detail, talking about that it is actually a state of technology which enables to use technology to sense our real world and make sense of it, like through intelligence, make decisions, make inferences, and then act on the real world through what we refer to as actuators or even through software to software. So basically through machine to machine communication. And the cool thing about this state of technology is that it enables us to do it at scale, meaning we can do it in large volumes, in large numbers. We can practically put a sense most of the world today, as long as the coverage is existent. So then we discussed what aspects of this technology or what is this state of technology all about. We discussed that we are now able to have greater computing capacity in smaller spaces, meaning in a nutshell, the size of computer chips are reducing and they're becoming very power efficient. So as a result, we can put these computers in, basically we use the example of putting it on top of every leaf on the planet if we need to, right? And then we were talking about wireless communication networks and how their coverage is ever expanding and how they're becoming faster, how they can transfer high volumes of data per second. And at the same time, how they're becoming more tailored towards the Internet of Things by becoming more power efficient and less cumbersome in their, what we refer to as protocol overhead is reducing drastically, right? Then we spoke about cloud computing and its implications, where if you want to do a lot of computing, you need a lot of computing power. So in the olden days, these used to be servers that you needed to purchase and take care of in your server rooms by having the right people. You need to think of aspects like disaster recovery, fault tolerance. So the introduction of cloud computing has taken away these risks, and it has made life a lot easier in terms of decision making because there aren't large down payments involved. You pay as you go. So as a result of that, you no need to spend millions or hundreds and hundreds of thousands in terms of purchasing the computing infrastructure, and you don't need to worry about disaster recovery and fault tolerance as well. These cloud computing platforms provide those for you. So it's a much easier decision and a much easier journey to embark on. And then we spoke about big data engineering. So we spoke about, even though how you have large computing power, if you do not use that computing power efficiently and intelligently, you will still not be able to process data. So we spoke about data parallelism and all of these tools, techniques, and frameworks that have been introduced to actually make processing of very large volumes of data and getting output in a timely manner rather than waiting weeks or days for it, typically trying to get it out in minutes or seconds or hours. And the different types of big data processing, where we spoke of real time, what we refer to as complex event processing versus batch data processing, which was about hindsight data. And the advancement of that, how it has aided in implementing IoT solutions quickly. And then we spoke about advancements of artificial intelligence. So there were questions about whether artificial intelligence is a necessity for IoT. The answer to that was no. But artificial intelligence and its advances in terms of making it very easy to implement by having a trail in terms of how to implement or how to enable artificial intelligence on data has basically made it much easier for us to apply AI and like perform a lot more complex, to realize a lot more complex use cases and derive greater intelligence out of this data. So it has made IoT a lot more useful. And finally, we spoke about IoT platforms and integratable devices. So we spoke about how IoT platforms help you to bootstrap your IoT project and perform proofs of concept very easily, where visualization, if this, then that kind of use cases and scenarios are easily implementable through a simple user interface and drag and drop functions. So you don't have to program those from scratch. So you just have the devices, you're able to connect to them, and you can implement a use case for a POC very easily. And at the same time, we spoke about how devices coming out today are highly integratable of the factory itself. So that makes it possible for us to come up with very novel use cases in terms of IoT, because these are connectable by default. Then we spoke about the two key benefits. We spoke about IoT in terms of it providing more information and more control with respect to your real world at low operating cost. And the key attribute to this low operating cost was that you could replace humans in terms of mundane and repetitive tasks, and those salaries, you don't need to pay them for mundane tasks. So rather than doing that, you can upskill or cross-skill humans to perform more, I would say, cognitive intensive tasks, creative tasks, so that you make the real benefit of the human brain. Whereas machines are far more efficient in terms of carrying out instructions that have been provided to them. They don't cost you every now and then. They don't charge salaries from you. So it's mostly about the down payment that you make initially. And afterwards, the operating cost is significantly lower compared to what it would be if humans were carrying out these mundane tasks. And finally, we discussed that the other benefit is that your decisions and your responses are better because you have more data, more real world data, so your assumptions are lesser. And they're of course faster because now machines can take the place of humans in terms of actually responding, right? So after that, we discussed, Asanka discussed the success formula to consider when planning an investment with respect to the Internet of Things. So basically, how do you embark and what are the aspects that you need to look at? So the first thing Asanka mentioned was that in terms of IoT implementations, there have been quite a lot of projects that failed, but they failed due to the fact that it was taken up because of hype rather than objectivity. So one of the key areas that Asanka stressed on was the fact that you should really work on the benefits and not follow the hype. IoT is a means to an end, not the end. It is only an enabler. But if it is used in the wrong place, of course, it won't solve the problem. So it's not IoT's fault. You have to look at how it would really benefit your organization. You should understand the regulatory limitations. This could be TRC regulations, privacy regulations that apply in your region and in your industry. And understand the dependencies of your total solution. So this could be power, this could be networking, this could be other legal implications. And basically, you need to understand, apart from you, what else are the factors outside your control that your solution's success depends on. And think about the maintenance cost as well from the beginning itself. Because if you don't think this through, you might make the wrong investments. You might not make investments that are required, so that once you get the project live and running, your maintenance might make life very difficult for you. And then, so that's the planning stage before you get into it. And during the implementation stage, you need to think of, these are the guys who are actually doing it, you need to think of what are the right connectivity protocols, right from the physical layer, right up into the software layers in terms of selecting, and then how you're going to store the data, what type of data, how frequent, what is the volume, what is the sensitivity to time. So all of this needs to be considered when selecting that. And then we discussed edge computing and analytics at the edge. This is to reduce the amount of weight that is put on the cloud or the backend because it can overwhelm any backend, and you don't want to end up with a Google-sized or Amazon-sized or IBM-sized backend to actually implement and make these kind of decisions and processing. So there we spoke about how you should try your best to push processing to the edge so that you distribute your processing. And also there are other advantages like being able to take quick actions. And then we spoke about remote monitoring and management, which is extremely important. And we'll be discussing that a lot more today, actually Ishrat, and I'll be setting the foundation for it. And how you need to look at the right level of security. You don't need to go overboard with the security, but at the same time, you should not take it for granted. And these are topics that, of course, can go into great detail when making decisions. And of course, we are open to questions, and you can reach us personally, individually as well through our email and LinkedIn profiles. So right, that is a recap of day one. Let's move on to day two. So the agenda today is, so myself, I'm Keshan. I'm an architect and I manage the IoT platform at Zone 24/7. Today we'll be discussing what a typical IoT architecture looks like. We'll be taking a very simple use case and talking about the components that will be used to realize it. And then I will discuss about the IT support versus supporting an IoT. So what are the key differences that we see when it comes to IoT? And Ishrat, who has plenty of experience in supporting IoT implementations and deployments, very complex ones, will talk you through some of the lessons learned and some of the first-hand experience that he has garnered through his years in supporting IoT deployments, right? So let's get to it. In order to start, I'm going to use a simple use case. We're going to call it an IoT Enabled Salad Bar. So if you want to visualize a salad bar, it is basically, if you've practically been to, say in Sri Lanka, Subway is there. So if you've been to Subway, you can visualize one very easily. So you've got your fruits, you've got your veggies, you've got your eggs and any other meat items you want. So imagine you're a company that is coming up with this salad bar and you go deploy this in one of our major grocers, supermarkets, even let's say food courts, right? So your business model is you don't keep people with the salad bar all the time. It's a self-service salad bar. And also you don't expect the grocer or the food court or anybody where you basically the place where you're hosting or keeping this salad bar to take care of it. All you want to do is, hey, give me a power outlet. Beyond that, I will run, right? So when you do that, obviously, you need to know when you're running out of your goods, when people start serving them and when they start running out of certain goods. Why is that? So when you know that, you can have a replenishing service, which could be a van or a truck, which is planning a route to take these goods to each salad bar and then replenish the salad bar. Second thing is, so these are salads, fresh goods. So they're very vulnerable to temperature variance. So we need to be able to calculate and measure this temperature variance and notify a technician or even somebody at the premise so that, hey, there's something wrong with the salad bar. Quickly, can you quickly go check? Otherwise, you're putting the lives of your customers at risk if this food goes bad. And at the same time, you're going to have LCD displays, let's assume, so that you can see what is on each tray. For example, hey, this is broccoli, this is a carrot, this is a lettuce, etc. And you need to know that the content on these LCD displays are correct in the sense on a tomato-based one, it's not showing lettuce, for example, and also that they're working. And finally, like I said, your operational model is to be independent of the actual location. So your network connectivity needs to be independent of the location. So things like connecting to the facilities Wi-Fi is not an option. Rather, you'd go with something like a 4G SIM that you would use, right? So moving on quickly, let me take a quick time check. Okay, so moving on quickly, if you look at the actual IoT scenario, this is what we're trying to do. So if I use my pointer, so I've got the salad bar and I've got a 4G link to a cloud IoT platform. And I'm going to use the IoT platform for two things. One is I'm going to implement a use case where if I detect that this salad bar or a particular salad is running out, then I'm going to trigger a business use case automatically to trigger the fulfillment partners through the ERP system. So I'm going to call the IoT platform is going to call the ERP system to say, hey, I'm running out. And that will trigger the fulfillment partners to automatically plan their route and get to the relevant salad bar to fill it in time. At the same time, I've got my technicians and the help desk where if the temperature starts going down, if the temperature sensors start reporting an error, if the displays start reporting an error, if let's say the cameras or the depth sensors that I'm going to be using to actually check whether the salad bar is running out of goods or the trays are running out of goods, if those start malfunctioning, I need to automatically alert people out there who will come and take corrective action, right? I should not wait for a human or a customer to report an error. Rather, I should know either proactively or at least as soon as it happens rather than some human having to tell me. So this is a salad bar which can basically express itself through IoT, right? So having understood the use case, okay, so there are a couple of abbreviations here. So ESL is basically electronic shelf label. And in this case, we'll be using LCD technology to have the same thing, but ESLs also have this technology called electronic signs or ink-based signs associated with it. But here we'll be talking about LCD-based displays, right? So if I draw you a very high-level block diagram of how this architecture looks like, so this entire component, let's say, are the components within our salad bar. And we've got our, what we refer to as our sensors or actuators or dumb devices, which will be our camera or depth sensor, which will be the LCD display and the temperature sensor. So we would typically have a hardware connection layer where it will be USB, Bluetooth, Ethernet, whatever is required. And after these sensors, through this hardware communication layer, it would connect to what we call the edge computer. So the edge is basically the last point in which significant computation, decision making happens on a computer, right? And this is also known as the fog layer compared to the cloud. So I'm assuming everybody knows what the fog is. If you've been to Norelli, you've seen it, right? So you have the fog layer, where in this fog layer, you would have, I mean, different software components to abstract out the temperature sensors, cameras, etc. And we'd have an inference engine that would take the input from the camera and then basically determine whether this particular tray is empty or not. And we'd have what we call an IoT agent. An agent is basically something which lies at a point, or in this case, the edge node, and represents the edge node's characteristics, attributes to the backend or the cloud of an IoT platform. So this is the component that actually abstracts out all of these layers and represents all of them into the IoT platform through a single communication channel. So as a result of that, this IoT agent will connect with the temperature sensor controllers, camera controllers, and it will be able to read, let's say, the temperature information and push it to the IoT platform. Through the field level inference engine, it will figure out events like, hey, is this tray running out, and push that event and information to the IoT platform. From the display control, it will get information like what is the content currently displayed on a particular LCD, and push that information to the IoT platform, as well as any errors that occur within these systems. And in the IoT platform, we will be able to easily program logic. Actually, you don't need to code this stuff. Most of this you can do through drag and drop. You'll be able to program or implement logic such as saying, hey, if I get a event saying the particular tray is empty or nearing an empty state, trigger this event to an ERP system, call this API of an ERP system, and that in turn would trigger a mobile device of a fulfillment person that will then plan a route to come and replenish that tray. At the same time, you'd have your what we refer to as the RMM portal. RMM is short for remote monitoring and management. And all of this, by the way, is in the cloud. So these things need to be web accessible from anywhere in the world to a user. And this RMM platform, this remote monitoring and management platform, will have the dashboards that show what's wrong, any errors that are out there. You'll be able to dig into it and see information. Hey, if you're reporting an error, what could the error be? So you can kind of do root cause analysis, troubleshoot, etc. Right? And at the same time, you'd have your display content management plugin. So that is for you to, as a user, say, hey, if I'm showing a lettuce anywhere, this is the image I want to use. This is the offer that I want to use. So you would have that kind of thing. And you would have your users who through the cloud, through a web browser would access, I mean, in this case, a mobile device, and these would access through a web browser, this system. And as a result, you'll have multiple instances, even thousands, millions of salad bars out there, which are visible through one IoT platform, which will automatically manage and escalate issues such as temperature sensors not working, LCD displays not working, pushing out automatically events about now, hey, I'm running out and things like that. And it will create a wonderful orchestration. And basically, we're able to now connect and make use of IoT enable this salad bar, right? So at the same time, we talked about the concept of fog computing. So when you look at these devices, right, these things of the internet, usually what happens is they directly communicate with the cloud. But the fog layer is basically an edge node, which basically lies typically within the same network, so that it can make quicker decisions. You can save on time rather than uploading all your data to a backend. You can do some processing and only upload the important information to the backend, so you can reduce your computing cost at this point. You can make faster reactions even if you're out of, let's say, out of network connectivity. You may still be able to execute fail safes, or at least notify somebody in the perimeter that, hey, something's going wrong. So this is the importance of the fog layer. Why you say fog is, it's like the cloud, but it's closer to the ground, right? It's closer to the location of the technology. And another view of this IoT platform, now we looked at a very specific implementation, but a more generic implementation or an architecture of an IoT platform would look like this. So you'd have your things at the bottom. These are typically dumb things, and they would have their integration APIs through communicating through various protocols. And this would connect with your fog layer. So if you take the fog layer, this can even be a mobile phone. This can be a small desktop machine running in the premises. It can be single board computers like Raspberry Pis or Intel NUCs, for example. So you'd have this kind of devices connecting to these fog layers usually. We also call these the gateway layers, right? So the gateway, why? These are the gateway between the IoT dumb devices and the cloud. And then you would have, of course, APIs that are exposed and your cloud system. So the cloud system is where your IoT platform, your big data processing and your AI systems, as well as your RMM, your remote monitoring and management systems reside. And at the same time, AI, by the way, can run, of course, at the fog layer as well. But here, to prevent complicating things, we mentioned that typically large AIs run in the backend, right? Now, another view of this same diagram, simplified view. You've got your dumb devices, you've got your edge node and your gateway. So your gateway typically operates as the fog layer. So these dumb devices can't typically do any computation on top of it. They will only be able to emit data and maybe respond to commands. So you've got your edge nodes that will actually be able to do some level of computation and commands and do complex communications with like HTTP to a more complex system, to a more user-friendly application level system. And these gateway components will basically function as a single point of communication for a site, let's say, and the IoT backend. And the IoT backend will facilitate all the IoT applications where we previously saw the remote monitoring and management systems, the ERP systems, mobile applications, all of which makes this IoT useful to the end user and exposes the benefits of IoT to the end user, right? So we've looked at the typical architecture of an Internet of Things, and please shoot any questions you have. We'll try to address as many of them as we can. And now let's look at what is different between a normal IT support operation and an IoT support operation. So number one, I've stated it here, scale. You're going to have a much, much higher number of devices to maintain usually in the Internet of Things. And why is this so important? So let's take this. So let's say your typical organization, the x-axis represents the number of devices and the y-axis represents the tech staff needed to support it, to maintain it, see if something goes wrong, check if something goes wrong, or if something has gone wrong in the first place, and then respond to it. So let's say you start off somewhere here as a small organization with a small IT operation of, let's say, 50 to 100 computers. And then you have a small IT team of, let's say, 5 or 6 people to support your servers and all of these things if something goes wrong. And as the number of your devices increase, if you do not have any, this is a very rare case, this red line, where you don't have any monitoring management system. If you're only dependent on humans, every, let's say, 100 or 50 devices, you're going to have to jack up your number of resources. So as you can see, when you're jacking up your number of human support staff, you're naturally going to be losing on the benefits of introducing this technology because your costs of maintenance are going to go up drastically. And let's say all of a sudden you decide that, hey, I'm going to now implement an IoT and deploy an IoT solution in my organization. Let's say we'll call it the IoT adaptation point. So at this point, you might go into thousands, hundreds of thousands, tens of thousands of devices. And what will happen to your number of staff if you don't have a solution is obvious. Something where what you were probably maintaining of, let's say, 500 devices here of, let's say, 50 people, 20 people, will all of a sudden start increasing to the hundreds when you start hitting 10,000, 20,000, 40,000 kind of devices somewhere here, right? So your number of staff is going to increase very high, very much. And at the same time, it's going to impact your costs and, of course, the benefits of IoT. It's going to outweigh the benefits. So that's why obviously organizations have some form of monitoring and management solutions. These can be network monitoring solutions and basic like things like SNMP or solutions that are available off the shelf. So as a result, you can keep your count low. One person basically can manage a larger number of devices. But still, when you start hitting the IoT scale of things, these basic tools will keep you at a point, right? But the efficiencies that you're trying to gain by putting these large volumes of devices still may be drastically hindered, because you have to still have a significant number of IT support personnel to actually maintain this thing. And that is why you really need to look at, do I have an IoT capable remote monitoring and management solution, which is tailored to my organization's needs, which has capabilities like self-healing, which will in turn enable you to have a relatively low or a fixed staff, and even the increments would be in a logarithmic scale rather than exponential or even a linear scale. So as a result of that, you will be able to keep the number of resources maintaining your IoT in check, which will in turn make it a far more practical solution for you. And these are some of the things that Ishrat will be discussing. And then finally, of course, the other aspect of the difference between a normal IoT operation and a normal IT operation and IoT support operation is the high level of heterogeneity. You'll have various types of devices and the different parameters, how you need to respond, the kind of commands and the kind of information, the kind of dashboards that you need, the kind of UI functionality that you need to support these things at scale can vary drastically. And you may end up with a variety of different systems to support, which has its own problems. And now I will hand over controls to Ishrat to talk about his experience in supporting the IoT operation.
Thanks, Ishan. Yeah, so let me first share my screen.
Okay, while Ishrat is actually getting ready with the screen, quick message to our audience. You can send in your questions to Q&A box, just like you did on Monday. And this time you have the upvote option for all the questions. So if you see a question asked by someone else before, you can upvote that question instead of asking the same question again. And one more thing, I have one more message to pass you. Might be a surprise message. I'm going to give that message right at the end of this program. So wait till the end towards the Q&A session. So I'll pass you the next message. Okay, over to you, Ishrat.
Trust everyone can see my screen. Yeah. All right. Okay. So, before we start, let's take a look at what do clients generally expect when it comes into providing support to them. So basically, it will like depend on whether the requests that are being generated and the tickets raised are addressed within the defined SLAs. Quick responses by the support team. No, it's not that automated message that comes through, but actually somebody physically talking, discussing the issues with the client. The least amount of back and forth communications with a client. So immediately the support team should be able to understand what's the client going through, and based on that determine what is the problem he's facing. And most importantly, in order to get the solution back up and running, rather than disturbing the client, have a way of remotely setting up and configuring the system so that it can be back again. So we do not want to disturb the client when trying to deploy our solution to the problem. So these are the aspects generally on a high level a client would generally expect as good support. So generally when it comes into providing support, what happens is we end up with a lot of tools required to provide this expected level of support. And most of these tools are very, it requires a lot of technical savviness, because let's take an example, you have several types of IoT devices. Right? Each of those IoT devices will be having its own set of remote monitoring and management tool. So when the solution whatever solution that you have proposed relies on the connectivity or the connectedness of different device types, to identify a problem, the support team should be able to manipulate or use all of these different tools which the different vendors have provided just to come to a understanding what's going on here. Another problem that we generally come about is like, let's say when we deploy solutions at different locations, we'll need to like maintain like what are the IP addresses of these lists, and it becomes very complicated later on if these IP addresses start to change. And performing, so even to get an understanding as to what's going on in the environment, you generally need to know remote desktop into that location just to get an understanding, just to analyze, hey, what's going on with this location. Another key factor here is repetition of the same issue. So this will eat into the performance of the IT support team, because generally what happens is a backlog of issues start to occur, and it will also eat into the SLAs. So if you can have a system which can, handle repetitions of issues, then your IT support personnel could be better utilized to address more pressing and more important problems rather than addressing these repetitive issues. So another part is like when let's say there's a resolution of an issue that needs to be carried out, will generally require the level 3 or a higher level support personnel to address these things, like to do a restart a service, restart an application, or maybe get the client to restart a device, which is not a good thing. Maybe reset or reconfigure the connectivity. So then that will also eat into your SLAs. The last three are more important, the most important one, that is when you have multiple system owners. So we will get back to the, we'll refer to this at a later stage. But for now, let's say the solution relies on several systems. So in order to extract whatever data that is required, there is a lot of red tapes involved. So for an example, to obtain logs from a system, you would need to get in touch with DevOps or some sort of personnel because of the security involved. So these will in fact eat into your SLAs. Multiple points of failure. So although individually IoT devices may be working as expected, but together connectedly, it may be not producing the expected result as what is expected. So then identifying the root causes becomes difficult. It becomes even more difficult when you have multiple tools designated just for that particular device type. So linking the problems among device types becomes a very difficult scenario. And finally, UEM tools do not facilitate in troubleshooting. So UEM tools are generally equipped for application and OS related updates and for security compliances. So if by any chance your IT support team is having a UEM tool related support, then they would need to do remote desktop, like do a team viewer connection, any desk connection, just to come to a conclusion of understanding what's going on with the situation. So let's take this as an example. So Ishan mentioned earlier about the salad bar environment. So over here, we will just dive into a bit more details. So over here, we have a temperature, humidity, and a field level indicator at each of these salad bar trays. So during the initial setup, we would need to set thresholds of each of these trays depending on the content they're having. So maybe some trays are having meat related content, which needs to be kept at a different temperature compared to the vegetables. So each of these trays are connected to the edge node computer, and if by any chance a trigger or a sensor trigger happens, all of this information are communicated to the edge node computer. Furthermore, let's say if a tray loses its connectivity with the edge node computer, that is also be escalated. And all of these information would then be transmitted to the support terminal, support staff using their support portal. And typically the support portal staff would need to look into addressing these issues when it comes to connectivity or sensor thresholds. So it's pretty basic stuff. But the actual value proposition of an IoT solution relies on two things. One is when different kinds of solution comes together to solve a problem. So we will get into that in a bit of a detail. So we are not just having one set of sensors, but instead several kinds of sensors all working in unison to provide the solution to solve that particular problem. It can be sensors or devices. And most importantly, managing the end-to-end life cycle of this connected solution. So let me take a real-world example to illustrate this thing further. So there was a particular retailer, a tier 1 retailer in the US, who had a bit of a problem, a major problem in obtaining accurate inventory from the store floor. So as a result, they were not getting clear insights into the inventory, and a lot of product misplacements are also happening. So you would tend to find trousers in the shoes area. And unlike over here, people do not go and keep the trousers back. Instead, they just dump it in a place and, so that's considered as lost inventory. Nobody thereafter knows what happened to that item. So as a result of that, there was a lot of inaccuracies in this inventory. And as a result, it impeded in these promotional opportunities. And also, this particular company did not have a way of identifying how the customers interacted with these promotions. Whether the people actually engaged with the product, did they try to see whether there were any other offers related to this product? Were there any online offers for this product? So there was no insights. They could not get to know whether the customers were getting engaged with these promotions or not. So the solution was to come up with a way to automatically obtain these inventory counts in the store flow, and based on that result, dynamically set these promotions on these customer-facing devices that were deployed in the store. So in order to carry out that process, so one of the devices that one of the devices that we use here was an RFID inventory robot. So we will get into a bit of the details later. The robot would traverse the store floor and read all the RFID tagged merchandise. All of this information later would be pushed to these electronic shelf labels. These are one of the customer interfacing devices. And furthermore, such promotions will be also pushed to these self-checkout kiosks. So people could actually interact with the product, see whether there are any reviews, positive reviews for this particular product, whether there are any online offers, and also facilitated for you to purchase an online product and have it delivered to your doorstep from the store itself. So various sorts of interaction capabilities were available based on the availability of the inventory data. So here's a video I would like to share with you all of a real world scenario. Yeah, so you can see our robot making its way onto the store floor. Sorry for the shakiness of the video. So this was a video obtained using phone cameras. So it's approaching the store floor to perform its scan, and it's trying to navigate through the aisles in the store. And while it's navigating through the flow to the store floor, it's reading the RF inventory data as of now. So pretty cool it seems though. And over here is the support part of this robot. So this was actually at 5:30 in the morning. This was a video which we took recently. So it was around 5:30 in the morning, which was around like 9 p.m. in the US store. So you can see the real live location of the robot in the store map. So as it navigates through the store flow. And also you have various amount of sensor data that is being published to the screens, and the real world live feed you can see over here as the robot makes its way through the aisles. All right, so you could see there are several tools which needs to be running in at the same time to ensure that the robot's operations are happening smoothly. So over here we have the electronic shelf labels pinned to each of these merchandise. So you can see how many devices just in this particular area. It was a shoe section only, the women's shoes department. Several thousand e-signs, electronic shelf labels were attached to each of these shoes. And over here, I would like to show a video of the of customers interacting with the kiosk, scanning for products, seeing whether there are any promotions available online. And also it allows customers to identify what is their final price that they have to pay at the checkout counter after taking into consideration of all the promotions and any loyalty-based promotions, etc. So, right. So let's get down to it. So how does this solution works? So we have the RFID inventory robot, which navigates the store flow and reads the RF tagged merchandise. And upon completion of the scan, all of these RF inventory data is uploaded to the client's database. And the client's database later pushes any promotional detail to the e-signs, electronic shelf labels. And also simultaneously, it will push any promotional details to the self-checkout kiosks as well. So what are the monitoring aspects involved in these each of these device types? So in the robot, it's like the traversal of it, the battery level, the RFID antennas, the connectivity of the robot, and then when it comes into the electronic shelf labels, the connectivity of the labels, whether the content was properly updated or not, licensing, battery levels, whether these e-signs were stolen or not, and self-checkout, also connectivity, pin pad failures, and barcode scan failures, application hangs, and any of the application hang means the front facing, the customer facing application, if it hangs, latency in client services. So these are the monitoring aspects when it comes into this entire connected solution. So what are the tools that we use? When it comes into the RF robot, we had to, we have a tool to manually move the robot in situations where it encountered uneven terrain. So then once it's manually, when you give assistance to the robot, then it needs to be repositioned. So that's another tool. Connection with the RFID readers, ability to configure which areas the robot has to scan. So there we have like around like 4 tools, and generally in each store we are like talking like 1 robot per store. When it comes to electronic shelf labels, we are talking about viewing the connectivity of the e-signs and the dependent devices. So there are access points which actually designated access points which communicate with these electronic shelf labels. So we are talking about like 3 tools there, and a particular store may be having around like, well, this is an underestimate, 50,000 e-signs. It's definitely more than that. You could see from the images how the amount of density was there in just the shoes department itself. And then you have self-checkout kiosks. We would need to retrieve logs, remote command execution, remote configuration. We're talking around like 5 kiosks per store. So all in all, in an enterprise-wide rollout of around like 1,200 stores in this particular client, we are like talking around like 1,200 RFID robots, 50 million electronic shelf labels, and around 6,000 kiosks. So what happens when IoT meets tech support? It's going to be a big problem. So one thing here is the knowledge base should be updated drastically, because traditional help desks primarily focus only on applications. Whereas when it comes to IoT support personnel, the IoT support people will need to understand how the sensors work and how these equipments work, how do they interface themselves, how do they communicate, what are the security matters, how do these sensors communicate with the applications. It's very technical based. Support team should work close with on-site personnel. So let's say you would need to have a technical, a field tech rather, sorry. A field tech should be able to give should be able to diagnose a problem and give feedback to the on-site, to the support team. And likewise, support team should be able to provide details on how to handle the situation to the field tech. Support team should be able to have access to deeper levels of information, like ability to pull logs, ability to log into terminals and execute commands. So this is where I mentioned previously about the red tape. So if you have red tapes involved for your support team and it prevents them to do these sort of tasks, it then eats into the SLAs and also impacts the solution at the end. And most importantly, what we tend to forget the most is that most of, half of IoT support means engaging with the vendors. So help desks needs to communicate very well with the vendors to resolve most of these IoT issues. And most of the time we tend to forget to consider the vendor's responsiveness when calculating the performance of your help desk. So something that we always tend to forget. So coming back to Heshan's graph over here, like he mentioned previously, so we have like if there is no proper tool to manage your deployment, then it's going to like you will need a lot of technical support staff to handle the situation. So, but if you have a correct IoT tool, which allows you to do the remote monitoring and management, which also has these self-healing capabilities, it drastically reduces the number of support staff that you need. So I can give you another example where another leading client had a lot of handheld POS terminals. I don't know anyone if you're aware of this Motorola MC3190 devices. Most of you would have seen these people using keels, these POS terminals. So there were like 35,000 POS terminals used by a leading tier 1 retailer. And can you guess how many people actually were required to manage this entire fleet of POS terminals? You'll be amazed. Only one individual person managed the whole whole fleet from the West Coast to the East Coast, 35,000 devices, one individual managed. So that's where the efficiency of the tools come into play. So before I wind up, I would like to discuss how to move forward in IoT support. So as the number of IoT device types starts to increase, it's advised to limit the number of tools which are required to support these teams. So if you start to, like I mentioned earlier, if every single IoT device vendor, if you use each of their own RMM tool to do the monitoring, it's going to get very complex. It's going to be very difficult for the team to come to understanding what are the reasons for this particular problem. So it helps to, so if you limit the number of tools, it reduces the complexity to get the data. As a result, it'll lead to quicker root cause analysis reports. And also it will increase the support team's performance, which will invariably lead to ability to meet SLAs. Then auto-execute remedial steps for repetitive issues, like I mentioned, self-healing capabilities. So this prevents the backlog of issues that are happening. As a result, increases the performance, meet the SLAs. Ability to execute commands on devices without the use of remote desktop features. So it reduces the downtime of customer devices, and also it increases the efficiency. So no need to keep track of IP addresses of each and every device that you are monitoring. And finally, a value addition comes here by proactive technical support. So let's say, based on all the information data that you have gathered, if you are able to share some insights with the customer, then it's going to be beneficial for you. Like for an example, you have gathered certain sensors related to a manufacturing process, and then you can share to the client, hey, here is a predictive maintenance report. In such a day, your devices are going to fail, right? So hence you might need to think of, of a backup, or either you upgrade your devices, or let's say for an example, collecting a lot of network information, network delay related information by using network thresholds. So then we can, come back and tell to the client, hey, Mr. So-and-so, you can see that during weekends, most of the time your network is lagging. It's difficult for your certain services to communicate. As a result, it's getting delayed. Your customers are getting even more unhappy. So maybe you need to start investing more resources during the weekends between 1 p.m. to 4 p.m. the Saturdays or on Sundays. So this will lead to more customer satisfaction, more engagement with the customer, and which will eventually lead for more business. Right, and that's it from my end for today. So yeah.
All right. Thank you very much, Ishrat, for your valuable inputs to the session. I think most of the questions Asanka answered offline, right? I can see most of the questions. Yes, actually typed the answers in. There is one open question that I can see. Maybe Heshan or Ishrat, if you can take that question.
This is the question on, is it possible to roll out software updates to edge nodes, right?
Yes, yes.
So yes, it is possible. And of course, that is the only option you should resort to. Trying to do this physically will be an epic failure, because you will be able to cover, because IoT is usually about how your devices are distributed as well. And if you have to visit those places, it's not going to be practical. There are ways to do it. See, the edge nodes are actually easier to update when it comes to the, let's say, the lesser powerful ones, which are not running operating systems like firmware.
Yeah.
So even those, like, you need to have a solution that is able to do that. And sometimes you need to go with a bespoke solution where you take a framework and you partner with somebody to build that bespoke part for you. But of course, good question, and never plan to go with physical access. Always remote.
All right. Thanks, Heshan. And guys, we are like about like 6 minutes over time today, the second day of this Internet of Things online short course. And the third and last episode of this series will be on coming Friday, same time, 7:30. So we'll be joining you with the same panel. And I told you that I have one more update for you. That update is we are going to award a virtual certificate for all those who participated in all the 3 episodes of this series. So if you have already participated in the first one on Monday and the second one on today, and please join us on Friday, and we'll be issuing you a virtual certificate from Apidem for your participation in this online short course on the topic of Internet of Things. So that's the news that I wanted to share towards a latter part of the presentation. So with that, I think, Heshan, if there's any like final notes you want to make, or maybe give a glimpse of what is to expect on Friday's session, and with that, we can actually wind up today's session.
Sure. So on Friday, we'll be building up on everything that we have discussed so far, and we'll be taking it a step further where when it comes to situations like we are in right now, where work from home is the norm, how your traditional IT tech or your support tech may actually be creating your operation or adding a lot of inefficiencies to it. And what you should do to actually relook at your technology and rearrange it if required, for it to better suit a work from home operation for your support teams. That will be the key message that we'll be talking about.
All right. So there's a question from Vikas. Do we need to register for Friday again? No. You will get a reminder tomorrow and another reminder 1 hour before the scheduled time. So all you have to do is clicking on the same link and joining. So yeah, I think that's about it. We'll see you on Friday, 7:30, and for the last episode of this series on Internet of Things. Thank you very much for joining in today. Have a wonderful evening. Bye-bye.
See you.
Okay,
Bye.
bye-bye.
Thank you.